So this lesson, we're going to be dealing with Unit 2 again. This is going to be our lesson 4. This is going to work with linear equations of a line. So our goal this time is actually to learn how to write an equation of a line. So one of the first things to pick up on is we know the slope formula can be rewritten in the form of what we call point subform. So the way this works is I can put this m over a 1, make it a ratio. And we know that with ratios, you can cross multiply. So this becomes then 1 times y2 minus y1, which is just y2 minus y1. And then we multiply the m times the x2 times x2 times x minus x1. So again, if I cross multiply, when you multiply by 1, nothing changes. Over here, we just want to multiply the m to the x2 times this minus this x1. So I should have y2 minus y1 there. So what happens is, instead of having, notice how it's point slope form, we only need 1 point. So I'm going to drop the y2 and just put y minus y1 equals m times x minus this x1. So this becomes what we call the point slope form of an equation. So if we know a point and we know a slope, we can use this equation to create an equation with the information. So if they give us this question, find an equation of line using the point slope form. So again, when a point is known and a slope is known, we can create an equation. And we can use the notation y minus y1 equals m times x minus x1, the point slope form. So if I give you an equation of a line that passes to the point 3, -2 with a slope of 2/3, what I can do is replace the y1 and the x1 with the given point. And the 2/3 is going to be our slope. So this becomes then y take away a -2 equals 2/3 times this x minus 3. Now I can clean this up a little bit because we have this double negative over here. So that's about the only thing I really want to do is kind of clean that up and just say, hey, this becomes then, we'll put this as y plus 2 equals 2/3 times x minus 3. So from there, they don't want us to stop with that. They want us to continue on and rewrite this equation in slope-intercept form. So I now have the equation in point-slope form. But what they want to do is they want us to move this into slope-intercept form, which means they want us to make it look like y equals mx plus b. So the first thing I would do is remove the parentheses off the right-hand side. So this becomes y plus 2. And then when you multiply the 2/3, you have to multiply through both terms inside the parentheses. So this becomes 2/3 times x, or we just call that 2/3 x. And then when you multiply the 2/3 times the -3, notice that the 3's are going to divide out into a -1, and -1 times 2 is going to be a -2. So it's going to give me that. Or you use your calculator and type in 2/3 times -3, and that would give you that -2 as well. So I got that, but I still need to get it into slope-intercept form. So I need to move this 2 over by subtracting 2 on both sides. So if I lose 2 there, I got to lose 2 there. So now the y is by itself. So y equals then this 2/3 x minus 4 would be the slope-intercept form of that equation. So that's what they want us to do, is they'll give us maybe a point and a slope. We can create an equation of the line using the point-slope form, but then they want us to maybe put it in slope-intercept form. Then there's this other form. It's called the standard form. Standard form, we have this ax plus by is equal to c. So the a, the b, and c, they cannot be fractions, and the coefficient of x has to be a positive number as well. So again, the coefficient of x must be positive, and there can't be any fractions present. So none of the numbers present can be fractions. So if I have the equation y equals 2/3 x minus 4, if we want to put this in standard form, we can do that. First off, we don't want any fractions. So the only number that makes a fraction is this 3. And since we have equations, we have this property and quality that says we can multiply each side by 3. So if I multiply this side by 3, I can now multiply this side by 3. So if we do that, we now have 3y equals, but notice this 3 has got to multiply through the parentheses. So when I multiply 3 times 2/3, notice the 3's will divide out and just leave you this 2x. And then you got to multiply the 3 to the -4 as well. So 3 times -4 is going to be a -12. Now, from there, we have to get the x and y on the same side of the equation. So what I can do is I can move the 2x to the side over here, but by doing that, it makes it negative. So that's going to be -2x plus 3y is equal to -12. Now, I don't want the coefficient of x to be negative, so what I can do is multiply each side by a negative. In other words, if I change all the signs on one side, I have to change the signs on their side of the equation. By doing that, this creates the equation 2x minus 3y is equal to 12, and that would now be in standard form. No fractions, and the coefficient of x is positive. So if the coefficient of x is positive, we're good, but since the coefficient of x is negative, we went on and changed the signs of all three terms. So another thing we may be doing is we may be asked to write an equation if we're given 2 points. So if we're given 2 points, this would be the strategy. First off, we're going to use the slope formula to find the slope. So let's do that to start with. So if I have the 0.08 and the 0.50, we can use those numbers to find the slope. So if m equals then, I want to call this x1, y1, and I'm going to call this point x2, y2. So I'm going to have 0 take away 8 on the top, and then 5 take away 0 on the bottom. So it's going to be -8 over 5. So it's going to be our slope. So use the point slope form to write the equation, and then write the equation in slope intercept form or standard form. So this middle step, use the point slope form to write an equation if we don't know the y-intercept. If we know the y-intercept, then we can go ahead and go down to the last step. Notice that 0,8 is a special point. Notice how x is 0. That means this is the y-intercept. So the y-intercept is actually going to be 8. So remember, if I want to go to slope intercept form, I now have y equals -8/5 x plus 8. That would be in slope intercept form. So let's just leave that one in that form, slope intercept form. So that was kind of straightforward because we knew how to find the slope using the slope formula, and the 0,8 was our y-intercept. Let's look at this one here. Let's put this one in standard form. So again, if I give you 2 points, I can use the slope formula to find the slope. So I'm going to have m equals this y2 minus this y1 over this x2 minus this x1. So I'm going to have 4 minus 4 over 7 take away a -3. So notice how, again, we have the 7 and the opposite of the -3 on the bottom. So we have 0 over 10, which turns into 0. So remember, in standard form, we have this ax plus this by is equal to c is what we're looking for. Notice though, the slope was 0. That tells me this is a special line. Notice how the y values are 4. So this tells me that our equation actually is simply y equals 4. So we're kind of done. Notice how there isn't a coefficient of x to worry about. There's not any fractions. The y's on one side, the c's on the other side. So that would be in standard form. And since it's also solved for y, that would also be in slope intercept form. So it actually satisfies both of them. So if I want to write an equation of a line here, notice how we can use this y equals k. So that's how our y values are both the same. So I can just simply say, hey, the equation is y equals 2. And since it's a horizontal line, we know that the slope is actually going to be 0 as well. So when turning the slope, we know that when it's 0, so if I did go ahead and do this problem, I could as well. So if we went on and found the slope, 2 minus 2 over -5 minus 7, that's how we would have got 0 over -12, and our slope was 0. So if we do determine our slope is 0, we know we have a horizontal line, and we just have this y equals 2. It's kind of like we did in the above problem as well. So when determining the slope and it's undefined, there was what we also want to call a vertical line. But notice how, again, the x values are the same. So that means our equation is going to be x equals -2. But again, if we miss that, if we are determining the slope, m equals 0 minus 1 over -2 take away -2. So we're going to have a -1 on the top. On the bottom, notice how there's a 2 and the opposite of a -2. Well, that really means -2 plus 2. That's going to be -1 over 0. And notice that you cannot have a 0 in the denominator. So we cannot divide by 0. That's going to be undefined. So since the slope is undefined, this flags us that the equation is going to be x equals h. So this one does not have a slope-intercept form. It does have a standard form, though. X equals -2 would be standard form. So if the slope and the y-intercept are given, we can kind of go straight to it. So notice how the slope is a -2 and the y-intercept is 4. So we can just write this as y equals -2x plus 4. Now, if I want to put this in standard form, I want to go one step further. That means I want to put it in ax plus by is equal to c. Again, I want to get the x and y on the same side. So if I add a 2x on both sides, or if I just move it over to the other side, remember, if you move a term to the opposite side of the equation, it changes signs. So if it's a -2x on this side of the equation, if it moves their side of the equation, it's going to become a positive. So this becomes then 2x plus y equals then a 4. And that would be in standard form. There aren't any fractions, and the coefficient of x is positive. So we have that kind of going on. So parallel lines. So remember, with parallel lines, if I kind of draw that out here, so a parallel line, if I draw a line in that direction, to draw a parallel line to that line, it has to run in the same direction. So if two lines run in the same direction, if they don't intersect, we would say that those two lines are parallel. So if I call this line 1 and this line 2, if they're parallel, then we have this notation L1 is parallel to L2. What we also pick up on is if the two lines are running in the same directions, that means the two lines have to have the same slope. So if I call M1 the slope of line 1, if I call M2 the slope of line 2, if two lines are parallel, what has to be true is the slope of line 1 must equal the slope of line 2. In other words, M1 equals M2. So if we want to write an equation involving parallel lines, let's see what we have here. So if we need to find an equation of a line parallel to a known line, the slope must be found from the known line. It should be known line with a little n there. Also, a point will be given that passes through. So if we have a point given as well, the point slope can be used to help us create an equation of a line if we don't know the y-intercept itself. So let's look at this example here. Write an equation of a line that is parallel to the given line and passes through the point 2, 1. So the given line, if I want to graph it, I'd have to solve for y, because that's how I would get the slope and the y-intercept as well. So again, to solve for y, I have to divide each side by 2. So y equals this 3 over 2x plus 8 over 2 would be 4. So if I was going to graph this line here, see if I can make an x and y axis. So we'll call that our x-axis. And then we need a y. That was our y-axis, I'm sorry. And this is going to be the x-axis. So if I was going to graph the line here, so this is my x-axis and this is my y-axis. So I have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 6, 7. 2, 3. So if I have 3/2, 4, if I want to graph that line, my y-intercept is going to be 4, 1, 2, 3, 4. And we have a slope of 3/2, so up 3, 1, 2, 3 over 2. So the given line would be this. So this would be the, oops, don't want that. So our given line would be here. Now, what they want to do is they want us to create an equation of a line that passes through the point 2, 1. So the line we're talking about is it passes through the point 2, 1 and it's parallel. So it's actually going to be parallel to the given line. So our line has to be, where do we go here? All right, so try like that again. So we need this point. So at this point 2, 1. And we want a line that's parallel to that. So it's got to run in the same direction. So we're looking for a line that kind of does this here, passes through that point, and it's parallel to the given line. So the given line, we can call L1. What we're looking for is the equation of this line right here. So at the equation of this line, we need to know two things. We need to know a point. Well, the point is 2, 1. We also need to know the slope of this line. Well, we do know the slope of this line because it's parallel to the given line. So we know the slope of this line has to be 3/2 as well. So using the point subform, I have y minus y1 equals m times x minus x1. I can substitute this information in and write an equation of a line. So we have y minus 1 equals 3/2 times x minus 2. So let's see if we can put this in standard form. So let's see if we can write this equation in standard form. So standard form, we want to remove the parentheses over here. So that's going to be y minus 1 equals 3/2 times x is going to be 3/2 x. And then 3/2 times this 2, the 2's will divide out and give you just this minus 3. So if I add 1 to both sides of the equation, that gets that y by itself. So now we have y equals 3/2 x minus 2. So that's slope intercept form, but we want to go one step further. We want to put it in standard form. So again, to get rid of fractions, we have to multiply each side by 2 to get rid of that denominator. So if I multiply this side by 2, I got to multiply this side by 2. So if we clean that up, that's going to be 2y equals, the 2's will divide out here and give me 3x. Then you got to multiply the 2 to the -2, which is going to be a minus 4. So again, I want the x to be positive, so I probably want to subtract the 2y on both sides. So if I do that, that's going to be a 0 equals 3x minus 2y minus 4. So I really want to add the 4 to both sides as well. So if I add a 4 to both sides, that's going to now become 4 equals 3x minus 2y. So if I switch that around, I can write that as 3x minus 2y is equal to 4. So that would be our standard form. So notice that if you move each thing around, so notice how if we had this 2y here, notice how when we move it to this side, it becomes negative. And notice how we have this this negative 4. If we move it to the other side of the equation, it becomes positive. And that's kind of the way we can kind of do it, is we can kind of switch sides of the equation by just changing the signs. So perpendicular lines is nothing we want to talk about. So let's look at two lines that are considered perpendicular. So let me create a little graph over here. Well, we'll probably do better than that. So let's erase there. Let's see if we can find a piece of graph paper under somewhere. Let's not do that. Let's do a different one. Let's see if I can find some graph paper here. That's a little bit better. Let's paste this down here somewhere. Let's make it a little bit smaller. So we're trying to get a little bit of a concept of perpendicular lines. Let's say I gave you the equation of a line. Let's say the first one is y equals, let's say, 2/3 x minus 2. So if I graph that line, the y-intercept is going to be -2. The slope of 2/3 means I'm going to go rise up 2 and run over 3. So that would be that. So if we graph that line, we have this going on. Now suppose I graph the line y equals -3/2 x plus 2. So that one, let's do that in a different color though. Let's make this one blue. So we're going to draw this one in blue. So the y-intercept is going to be 2. And we'll go down 3, 1, 2, 3, and right 2. And we get there. So if I draw that line, so when two lines intersect and form a right angle, these lines are said to be perpendicular. So this line 1 and this line 2 are going to be perpendicular. And notice that their slopes are really close, but not quite. So what we pick up on in math is if you multiply the slope of one line by the slope of the second line, if that equals -1, then those slopes are actually considered perpendicular. So if I have 2/3, and if I multiply that by this -3/2, notice how this becomes like -6/6, which turns into a -1. So that does hold true. So we would say these lines are perpendicular. So we would say M1, or I'm sorry, not M1. So we would say line 1 is perpendicular to line 2. And notice that their slopes, they're what we call reciprocals for one thing. Notice how one's 2/3 and one's 3/2. So notice how it's turned upside down. That's referred to as reciprocal. But notice how they're also one's positive, one's negative. So we refer to these as opposite reciprocals. So when it comes to perpendicular lines, what we pick up on is their slopes are said to be opposite reciprocals. So if line 1 has a slope of 3/4, what would be the slope of line 2 for them to be perpendicular? Well, 1 is I have to change the sign, and 2, I'd have to flip it. So this becomes then -4/3. So that's how the 3/4 becomes 4/3. And since it's positive, the second slope's got to be negative. So our next question is, write an equation of a line perpendicular to 2x plus 3y equals 1 and passes through the point 2, 1. So the given line is here. So what we want to do to start with is solve this equation for solve it for y to determine its actual slope. So if I have 2x minus 3y equals 1, we want to solve this equation for y. So I got to subtract the 2x first to get that on the other side of the equation, or you can just move to the other side and call it negative. So this is going to become a -3y, and this is going to be a -2x plus 1, since these are not like terms. And then to get y by itself, you have to divide by a -3 here, as long as we divide this side by -3. So this becomes then y equals, and then a negative divided by negative is going to be a positive. That's going to be 2/3 x. And 1 divided by -3, that would just stay as a fraction, -1 divided by 3. It would just be a negative. So notice that the slope of the given line would be 2/3. So the slope of my line has to be the opposite reciprocal of that. So that's going to be a -3/2. Okay. So now what we can do is we have this point. The point given was 2, -1. So the slope we know now is this -3/2, and a point we know is 2, -1. So by using that information, so again, our slope was -3/2 and 2, -1. Using that information, we can create an equation of a line. And we're going to put this one in slope-intercept form. So first off, since 2, -1 does not represent a y-intercept, we have to use the point subform. So y minus y1 equals m times x minus x1. So remember, the 2 is going to be the x1, the -1 is going to be the y1. So this becomes then y take away -1 equals -3/2 times x minus x1, which is 2. So that's how we have this double negative over here. That's going to be y plus 1. Here we have to multiply the -3 through the parentheses, the -3/2 through the parentheses. -3/2 times x is going to be -3/2 x. And you multiply -3/2 times -2, the 2 and the 2 will divide out, and a -1 times -3 is going to actually be a positive 3. Or again, you can multiply -3/2 times -2 using your calculator. So we're almost there. We just got to get the y by itself. So if we subtract 1 over here and subtract 1 over there, that will be in now slope-intercept form. So y would equal then -3/2 x plus 2, and that would be the equation of line in slope-intercept form. So I like these types of questions here. It makes you think a little bit more. Alrighty. So that concludes this lesson on working with writing equations of lines.